that is diffraction as well as polarization. Okay, the wave optics was explained by Heisenberg, right? Okay, now here wave optics. Before moving to the Heisenberg principle, then here we need some of the points. That is first one, wavefront. What is a wavefront? Wavefront is a point of disturbance. Wavefront is a point of disturbance. Here an example I will consider, students. Consider one example. I'll consider a calm swimming pool. What I consider, students, here? Calm swimming pool I'll consider, right? Calm swimming pool for homogeneous medium. For homogeneous medium. If I throw one stone there, then this is the point. That is the point of disturbance. Central point. That is the point of disturbance. Then what will happen? Then you start producing the waves in all the direction. Then you start producing waves in all the direction. Only the first wavefront, that is the phase, the crust is joined. Crust only a crust joint, otherwise only a trough joint. That is known as what we call it is a wavefront. What we call it is a wavefront. Wavefront is the same phase of oscillation. Same phase of oscillation is known as what we call it is that is wavefront. The tangent drawn on same phase. It may be crust or it may be trough. That is known as what we call it is a wavefront. Yes, I hope remember this. Wavelet as well as wavefront. These two concepts are important. Okay, for next upcoming lectures. Okay, now here the wavefronts, the different wavefronts are there. First one is spherical wavefront. First one is spherical wavefront. What is spherical wavefront? The point source produces a spherical wavefront. Consider here. I'll consider a calm swimming pool of a homogeneous medium. If I throw one stone, then what happens? It start producing the rings. Yes or no? How it is there? That is in the form of spherical rings it is producing. Yes, that is known as what we call it is a spherical wavefront. Next one is a cylindrical wavefront. What is that? A cylindrical wavefront. Which one will produce a cylindrical wavefront? The plane source will produce the cylindrical wavefront. Plane source will produce the. This is the plane source will produce the cylindrical wavefront. Yes, remember the plane line. Otherwise, linear source will produce the cylindrical wavefront. Okay, I'll move to the next one. That is plane wavefront. Which one will produce the plane wavefront? The infinite source of light will produce the plane wavefront. Ocean waves. Just I'll give you an example. Ocean waves. Okay, next Heisenberg principle. What Heisen stated that is each point of on a wavefront. Each point on a wavefront act as fresh disturbance. Each point on a wavefront act as a fresh disturbance. Assume here consider, students. Right? This is a homogeneous medium. If I throw the point source, this is the point source. Then what happens? It start producing the waves. Okay. Just if I draw the only a crust or trough joint, then that is what we call is a front. Then this wavefront again contains fresh wavelets. It contains again fresh wavelets. Again it start producing the waves. Again that is drawn. Okay, that is known as first point. The Heisenberg first principle. Each point on a wavefront act as fresh source of disturbance of light. Fresh source of disturbance of light. This is okay. This one. Okay, that is the fresh. Here I am marking the point. Fresh source of disturbance. Next, the new wavefront at any time later is obtained by taking a forward direction. This will produce a disturbance. I will join this. Again I will join this one. Again I will join this one. Again I will join. Again by drawing this one. Not only forward, backward also we can draw. But backward merge at the center. Only we can get the wavefronts in a forward direction. That is known as what we call it is Heisenberg principle. Yes, I hope you remember the two principles of Heisenberg. That is first one as well as second principle. Right? The forward wavefronts are present. Okay. Law of reflection using Heisenberg principle. Then we study law of reflection using ray of light. What we study, students? Ray of light we study. But here consider a plane glass XY. But students, here we are incidenting. Not a light. Here we are incidenting wavefront. We are incidenting. What we are incidenting, students? Here wavefront. Waves we are incidenting by drawing the tangent. Wavefront we are incidenting. Right? Then this explains law of reflection of a that is ray of light. Both will match. That I am stating. Actually, that get matched. Okay, by incidenting wavefront. Part of light get reflected. Assume here. I'll incident the light. Now what happens? You start producing the waves. Bigger waves start producing. Yes or no? By drawing the tangent. So now draw the tangent. So just this is wavefront incidented. Again, it get reflected. What it obeys? It obeys same law of reflection. That is sin I equals to sin R. I equals to R. Incident ray is equals to reflected ray. The next one, incident ray, reflected ray, normal all lies on same ray. That whatever laws we studied in ray of the same law. Okay, just remember the formula. Okay, now the law of reflection using the Heisenberg principle, wave theory. Yes, this also obeys law of reflection of a ray of light. What it states? Then here also it obeys. As here I am incidenting the wavefront, the part of light get refracted. What happens here? Part of light get refracted by drawing the tangent. It makes an angle, refracted angle as well as incident angle. Now I'll write the formula. That is Snell's law. N1 sin I equals to N2 sin I. This also obeys N1 sin I equals to N2 sin I. Yes. I hope you clear, students. Okay, next one. Coherent source. Okay, coherent source as well as incoherent source. What is coherent source? Okay, coherent source of light, those light which emits the light waves in a same wavelength. In a same wavelength and same frequency and same phase is known as what we call coherent source of light. What is a coherent source? The wave, that is which emits the light of wave having same wavelength, frequency and same phase is known as what we call it is coherent source. What is incoherent source? In incoherent source, the emitting light having different wavelength as well as different frequency and different phase is known as what we call it is incoherent source of light. Okay. Now interference. Interference takes place coherent as well as incoherent sources. Okay, two coherent sources. Important students. Here, formula is most important. We'll consider two sources. Any two coherent or coherent sources. Two coherent sources are moving in a same directions. Two waves superpose with each other. Assume this is one wave and this is another wave. Okay, both having same phase as well as same amplitude, same wavelength. Then what happens when these two waves are superposed? Then the resultant wave is maximum. By combining these two amplitude, the resultant wave becomes a maximum. The superposition of two or more waves produces interference pattern. Produces interference pattern is known as what we call it is interference or superposition principle. Okay, now here if one coherent here we consider that is incoherent sources, one is crust, another one is trough. Then when these two are superposed, what we can get here? We can get a dark line we can get. Okay, just a straight line we can get. It is a dark line we can get. Okay, now then when crust as well as troughs are combining, then what we observe on the screen is bright fringe as well as dark fringe. When the maximum intensity of light, I'll come to that point also. When the maximum intensity of light clubbed with each other, then what happens? It produces a bright band. When minimum intensity of light clubbed with each other, it produces the dark bands. That is here only. When this crust and crust superposes, it produces the maximum. That is the bright. When crust and trough combines, then it gives the straight line. That is the minimum dark fringe. Yes or no? Dark band as well as dark fringe activities. Okay, now here how many waves we consider, students? Two waves. That two waves having a different phase. That I will write here, students. E1 equals to A sine omega t. Then the next one, E2 equals to B sine omega plus pi. Then some angle changes. Then phase shift. Here I am taking the phase shift. That is the first wave and this is the second one. E1 equals to A sine omega t. E2 equals to B sine omega t plus pi. Okay, now when these two superpose and these two waves superpose with each other, it produces the interference pattern. What it produces, friends? It produces the interference pattern that I am writing here. E equals to E1 plus E2. Then combine it. Right? I will apply the trigonometric functions. Okay. Here I will go to the next one, that is, students. Then what is the resultant amplitude? Resultant amplitude is A equals to root of A square plus B square plus 2AB cos pi. What is the formula? Resultant amplitude. This one is the resultant amplitude. When two waves are superposed with each other, the resultant amplitude A equals to root of that is root of A square plus B square plus 2AB cos pi. Our parallelogram of law of vector in first place. Okay. Next, what is the angle made by these two? The angle tan pi equals to B sin phi divided by A plus B cos pi. What is the angle made, students? Angle made is okay. Now, how these two are related? Intensity and amplitude. Intensity is directly proportional to square of amplitude. Intensity is directly proportional to square of amplitude. That I am writing here, students. Now, intensity equals to the square and root get cancelled. What I am getting here, students? A square plus B square plus 2AB cos theta. Remember this point. Remember how these two are there? Intensity and amplitude. Intensity is directly proportional to square of amplitude. And remember this formula also. Very helpful by solving the problems. Okay, students, I'll go to the next one. That is condition for constructive interference as well as destructive interference. What is constructive interference here? The constructive interference is the intensity is maximum. Constructive interference intensity is maximum. When the intensity is maximum, the cos pi equals to 1. When cos pi equals to 1, the angle is 0. The cos pi equals to 1, the angle is 0. That I am writing here. In constructive interference, I should be maximum. Intensity should be maximum. When it is possible, when cos pi equals to 1, that is pi equals to 0 degree. Pi equals to 0 degree is nothing but what? Two waves are in phase. Then here the phase difference equals to. Okay, first the path difference equals to. First I will take the phase difference. Pi equals to 2 pi n. 2 pi n or 2n pi. Remember this difference. What is the phase difference? Phase difference is 2 pi n. Then path difference equals to. The path difference equals to, that is n lambda. Path difference equals to n lambda. Just you will note on this. Path difference equals to n lambda. Right? Now, that is I max equals to I maximum, intensity maximum equals to direct proportional to A plus B whole square. For I maximum equals to or directly proportional to A plus B whole square. This also remember, students. What is the path difference in constructive interference? Path difference in constructive interference n lambda. What is the phase difference? 2n pi. What is the phase difference? 2n pi. Very important by solving the problems. Okay. I'll go to the next one. Here, condition for destructive interference. What is the destructive interference? The intensity is minimum. When the intensity is minimum, the cos pi equals to 0. Cos pi equals to 0. When the cos pi equals to 0, cos 90. When the cos 90, then cos pi equals to 0. Right? Pi equals to 90 degree, then 0. Here. This is destructive constructive interference. Actually, this is cos pi equals to 0 volts. Cos pi equals to 0. That is 0.1 I written. That is nothing but 0. When cos pi equals to 0, pi equals to 90. Yes. What is the phase difference? Phase difference is 2n plus 1. 2n plus 1. If you substitute n equals to 0, what we can get? Just 2 pi, right? That is here the conditions. Okay, now what is the path difference? Path difference equals to lambda equals to 2n plus 1 lambda divided by 2n plus 1 lambda divided by 2. And what about here? The minimum intensity I minimum is directly proportional to a minus b whole square. Remember students, there in maximum amplitude is a plus b whole square, here a minus b whole square. Okay, this will be very helpful by solving the problems. Remember what is the path difference? 2n plus 1 lambda divided by 2, and what is the phase difference? 2n plus 1 pi, right? Okay, next one, this Young's double slit experiment. What the Young's double slit experiment? The Young's double slit experiment, he considered two slits. One is single slit and another one is double slit. Okay, otherwise two slits he considered. When source of light passed through the slit, what happens? When source of light passes through the slits, then it divides. Again, those waves are superposed with each other. Then on the screen he observed alternate dark and bright fringes. What he observed? Alternate dark and bright fringes he observed is known as what we call this Young's double slit experiment. Yes or no? Okay. Here, just move to the formulas. In Young's double slit experiment, the first fringe, that is a bright fringe. What is the formula for bright fringe? Okay, bright fringe. When we can get a bright fringe? We can get a bright fringe in constructive interference. Yes or no? What is the path difference in constructive interference, students? N lambda. Yes, here I will use the formula, that is a bright fringe. The bright fringe constructive interference, the path difference is N lambda. Yes. Okay, now by substituting all the values, what we can get? The fringe width equals to beta equals to lambda d divided by d. Here beta is a fringe width, then lambda is wavelength, and d is a distance. Distance from slit and screen. Okay, what about small d? Small d is distance between two slits, S1 and S2. Yes, remember the formula, this is very helpful. Beta equals to lambda d divided by d. Yes, for bright fringe. Very important ones. Okay, I'll move to the next one. That is dark fringe. When we can get a dark fringe in a destructive interference. What is the path difference for destructive interference? That is 2n plus 1 lambda divided by 2. Yes. Okay, now I'll directly move to the fringe width. Here also we are getting the same fringe width. Beta equals to d lambda divided by d. What we are getting in students? Beta equals to d lambda divided by. Okay, just we are substituting the values for different values. By different value observed, then what we can get, students? Fringe width lambda d divided by d. I hope you clear. This is very important, students. Very important. Fringe width is very important. Okay. I'll move to the next one. Diffraction. What is the diffraction? The bending of light. The bending of light in obstacles is known as what we call it is diffraction. Okay. Here consider students. This is a slit. Source we are incident. What we are incident? Source of light we are incident. What happens? It get bends. It get bends. That is bending of light. The bending of light in an obstacle is known as what we call it is diffraction. Here we are observing again students. Here we are observing the fringes we are observing. What we are observing? Fringes we are observing. That what type of fringes we are observing here? By incidenting light. By incidenting light, central maximum. What we are observing here students? Central maximum. This is the central maximum. When you go away, then it get decreases. Get central maximum, again it goes away, it get decreases for a diffraction pattern. Here I'll write the formula, that is central maximum is the bright fringe. Okay, diffraction is not visible. Just to ask this one. Okay, diffraction is not visible after few order of diffraction, because it moves away, that its intensity get decreases. Okay. So what is the formula we have students? The formula n secondary minima. N secondary minima. The slit can be divided into 2n equal parts. 2n equal parts. The formula is that is theta d sin theta 1 equals to lambda. Right? For second theta 2 equals to, that is okay. For nth one, what we can get here students? For nth one, that is theta equals to n lambda divided by this is for minimum. This is for minimum. What is the for? Again, nth secondary minima. Again, nth secondary minima for second order, that is n plus 1 equal parts. Then what we can get students? That is theta equals to 2n plus 1 lambda divided by 2. Remember this. Lambda divided by 2. Yes, these two very important formulas by solving the problems, diffraction problems. Okay, students, polarization of light. Right? This polarization of light here, when electromagnetic wave passed through polarides, then we can get a polarized light. The polarized light we are representing like this. That is parallel to the plane, or we can represent dot also, polarized light. Okay, now here Malus law. What Malus law states? In a plane polarized light of incident on analyzer is directly proportional to cos theta square. That is, intensity is directly proportional to cos theta square. The proportionality constant is removed by. Yes, that I am defining here. Polarides. When a beam of plane polarized light is incident on an analyzer, the intensity I of light transmitted from analyzer varies directly the square of cosine angle. Right? That I am writing here. I is directly proportional to cos theta square. Right? Now, by removing the proportionality constant, what we can get students here? Right? That is I equals to K A square cos square theta. Now, this is equation I equals to this cos square A is K A square is nothing but what? I naught. I equals to I naught cos square theta. Right? Okay, next. Polarization by reflection of a Brewster's angle. Now, here we are incidenting a polarized light. What we are incidenting? Unpolarized light. Incident on a slab. Okay? Incident on a slab. Then what happens? The part of light get polarized. The polarized light get reflected. part of light get refracted. That is, maybe it may be polarized or unpolarized. Here I will write the formula. That is n equals to tan pi. That's the formula, students. N equals to tan pi. Here I am using a Snell's law. I am using the Snell's law. N equals to sin I divided by sin r. I have taken as a polarized incident angle theta p. Now what I can get by simplifying this one, r. Here r is there, that r I will write in terms of, here this is refracted angle r equals to 90 minus theta p. Then n equals to, here Brewster's angle n equals to tan theta, remember this, n equals to tan theta. I hope you clear, students, the Brewster's angle. Okay. Now uses of a polarized glasses. Where we are using polarized glasses in sunglasses. We are using. Next one, polarized filters, laboratory purpose. Then headlight of automobiles. Then three-dimensional motion pictures. Then window panes as well as window shield automobiles. Okay. These are the polarized glasses we are using. I hope you clear this, students. Okay. Now I discussed all the synopsis of a wave optics. Okay. Now I will solve some of the problems. Okay. Just go through all the formulas. I will begin with problems. Take 1 or 2 minutes. Okay, students. Here I will begin. First question. By corpuscular theory of light, the phenomena which can be explained is, what phenomena it can explain? Corpuscular model of light, right? The corpuscular model of light explains the law of refraction. The corpuscular model of light is nothing but that is Newton written an Optica book. He considered initially by explaining ray optics, he considered corpuscular model of light. That is, corpuscular model of light is nothing but the tiny particles having negligible amount of mass is known as what is called corpuscular model. What it explains in Newton's law? The ray optics explains law of reflection as well as law of refraction. Here only the given law of refraction. Okay, it can't explain interference as well as diffraction and polarization. Only it explains refraction phenomena. It explains refraction as well as reflection phenomena. It explains. Option A is the right answer. Okay, we'll move to the next one. Two coherent monochromatic light beam of intensity I1 and 4I, right, are superposed. The maximum and minimum possible intensities. In the resultant beam are. So, students, this is very important. I told you maximum and minimum intensity. We can use the formula. First, I will take maxima. I max. What is the formula? I1 plus I2 whole square. Solutions. I1 plus I2 whole square. Yes. Amplitude I1 plus I2 whole square. Just this one. This I will write in terms of root I1 square and this is root I2 square. Yes. Now I substitute. I max equals to, that is what our value here? I plus this is 4I whole square. Yes, students? Yes. Just apply the formula. Root I1 plus root I2. That is the form of A plus B whole square. That is the formula A plus B whole square. Here, students, this is simplified. Just apply the A plus B whole square formula. Then you can get an answer. What we can get here? 9I. What we can get here? 9I. Okay, I hope you clear. Next one I will do. That is I minimum equals I minimum. What is the formula? That is root of I1 minus root of I2 whole square. Yes? Now, I minimum equals to why I am going to root? Because students, that is intensity is directly proportional to square of amplitude, but amplitude we can write that is root of I. So this is root of I minus root of 4I whole square. Just again apply a minus b whole square formula. What I can get students here? I minimum equals to 1. But I can get I minimum equals to 1. Here 9I and here 1I. Option C is the right answer. Okay. I hope you clear this one. I'll move to the next one. Now, if the ratio of intensities of two waves is 1:25, then the ratio of their amplitude will be, right? Okay. Intensity the given students here. I1 is to I2 equals to. This is A1 square divided by A2 square. That is amplitude square divided by amplitude 2 square, right? Because both are directly proportional. Now, this is 1 divided by 25 root. I'll do directly square. 1 divided by A1 divided by A2. Now here A1 divided by A2 equals to what I can get here. Separate the root. 1:5. Option D is right answer. Okay, how to clear this one? So let's move to the next one. If two waves are represented by y1 equals to 4 sin omega t and y2 equals to 3 sin omega plus pi by 3 interfere, then superpose at a point, then the amplitude of resultant wave will be. The amplitude of resultant wave will be. So two waves are there, and here amplitude 1 and this is amplitude 2. Okay. Now again the phase they given, phase shift they given. I will use the formula. What is the formula? A equals to root of A1 square plus otherwise A square. Root of A square plus B square plus 2AB cos phi. Yes. Okay. Now amplitude is, first amplitude is A, that is 4 square plus this is 3 square plus 2 into 4 into 3 cos this is pi by 3. Yes students, now A equals to root of here 16 plus 9 plus this is 24, that is 12, that is 4 2s are 8, 8 3s are 24, 24 divided by cos pi by 3 is nothing but 1 by 2, here 12, add up this one students, A equals to root of 25 plus 12, 25 plus 12, that is 37. Yes students, okay, 37 approximately we can get 6.01. Yes or no? What is the answer students here? 6. Simplify. Okay. I'll go to the next one. Monochromatic green light of wavelength 5 into 10 to the power of minus 7 meter illuminated a pair of slits 1 millimeter apart. The separation of bright lines on the interference pattern formed by the screen 2 meter away. Yes students, what they are asking, the separation of bright lines on an interference pattern. Just use the formula, that is Young's double slit experiment. What is the fringe width? Beta equals to lambda d divided by, yes or no students? Yes. Okay. What is the wavelength? 5 into 10 to the power of minus 7. Separation distance to divide by, that is 1 millimeter, 10 to the power of minus 3. 10 to the power of minus 3. Yes? No. How much I can get students here? 10. 6, 10, and this goes up means 10 to the power of 10 is nothing but 10 to the power of 1. This is 10 to the power of 3. 10 to the power of 4 plus 4 minus 7. That is 10 to the power of minus 3. Nothing but what? Beta equals to 1 millimeter. Beta equals to what, students? 1 millimeter. I hope you clear, students. Okay. Clear? Okay, thank you, students. Next class, I will solve the remaining problems. Thank you.